Okay, let us start now. I will make my audio. Yeah, am I audible first of all?
Yes, sir,
So
audible.
I will start my the recording. I hope I am audible. And let's see. I will share the screen. Let me know if you are able to see the screen.
Yes, sir, we're able to.
Okay, great. Thank you. So we can start today. Uh, we have covered the very basics or an overview of the architecture that we are going to follow as a pipeline. Not only a pipeline, there are other uh, tools which are embedded or inbuilt within when we say Azure DevOps. We know Azure DevOps means we know Azure Repos, Azure testing, Azure pipelines, Azure Artifactory, okay, and Azure releases as well. So in doing so, we have to build the artifacts. Whenever we are creating a pipeline or wherever we are integrating with the pipeline, let me make it full screen. So first of all, we generate the artifacts. Artifacts are important derivatives of the project. That is, we have to store those artifacts, publish those artifacts, and version those artifacts, because in various releases you have a different set of or the earlier versions of the artifact. Maybe the artifacts will remain the same or artifacts will keep on increasing as we proceed with the subsequent releases. Okay, because a project is a very dynamic thing. So what is delivered in this phase of the project can vary in the next phase because you are adding up more deliverables. So you define the artifact. So the build artifacts are the output files produced by your build process, because building your code, I mean, the developer has given you the code, and when you build those into some artifacts, it is needed because you have to package them. You have to build into as an image and put it into a container for deployment. All these things are done as a build process and which are having an output of artifacts. So whenever you will often hear the term artifact in an IT project. Okay. So artifacts serve as the bridge between your build and the release pipeline. Whatever you are building and whatever you are releasing over the build and the release pipelines are nothing but the artifacts. You build the artifacts and release those artifacts as deployable artifacts in your pipelines. Okay. Publishing the artifacts, you have to publish those build artifacts. Publish build artifacts task. So these are inbuilt tasks. When I say so you automatically get some inbuilt tasks. Okay, so this you have to include in your pipeline script as a task. Will upload the specified files or directories to Azure Pipelines artifact storage. You are publishing, you are storing. So this artifact has been created or built. It can be a jar file, it can be a war file, or it can be any artifact of any kind, which is derivative of the build. Okay. Now you have to push it and store into some folder structure. These are the build structures. That is, you save it in the various stages of the, this is the Artifactory. It can be Azure Artifactory, it can be JFrog, it can be Nexus, whatever Artifactory you are using. Okay, so what you do, you according to the release, according to the versions, you store the artifacts in the various organized folders. Because later on, these artifacts, these are sort of history files that are used for deployments, releases in the release pipelines. Okay, so you build it with your build pipelines, and then you, with a release pipeline, you store, and then you release. Okay, so you get, you store, you get from this repository or this Artifactory all the artifacts that are needed for the deployment, get and deploy. With, of course, release. So this is a release pipeline. So the release pipeline is nothing but they get the artifact, they package it and release it to the various. This can be a pre-production server, or it can be a production server, or it can be a testing server. Test, prod. And in the release, you will have, approval gates. So you cannot release it to pre-production or production or to test server without a proper and prior approval. Approval can be given by the project managers or the leads or the operations manager, whatever it is. Because all this architecture, all this infrastructure is owned by whom? Can anybody tell me? All this infrastructure is owned by, see, this is the development portion. This is the DevOps. So what is left? All the infrastructure, that is networking, servers, storage, all these mechanisms, restore and backup mechanisms, all these are maintained by whom? By which team? Quality storage and all those, quality maintenance, feedback, monitoring. Who does it? All these servers are owned by whom? All this environment is owned by whom? By? Sorry, can you speak a bit loud?
Operations team.
Yes, exactly. Operations. They are the owners of the entire infrastructure. So you need operations manager to approve, or the project manager can approve. So there are various approval gates in the release pipeline. So, and there is an automatic mechanism that you send whenever they are waiting for your approval. Approval mail will be sent to the project manager or the relevant managers for them to, or maybe the development lead. It is whatever the architecture, whatever the organizational architecture is or organizational structure is, depending on who needs to give the approval. So although all the mails will be sent to the respective persons, and it will wait. The pipeline will not be executed unless and until it gets an approval. That is called the release pipeline. So there is a mechanism of approval and go ahead. So after an approval is done, so it will be deployed. That is a part of the release pipeline. But whatever integration and build will be done through build pipeline. This is one very important feature of Azure DevOps, not available with other pipeline softwares or tools. Azure DevOps provide you can segregate out one big pipeline into build pipeline and release pipeline. So you name the artifact and you do the versioning of it. And after they have been deployed, you can say configure how long the artifact should be kept in the Azure pipeline. So that is your retention, your aging of the artifacts will be determined. So there can be a cleanup mechanism, because there can be, for every release you are storing all the artifacts. Okay. So at one point of time, maybe after a month, so it is according to the company's policy that after it has been deployed to the production, we may, once the artifacts age 1 month, you may, or maybe 1 year, it depends on the company's policy, you may invoke the cleaning operations to clean up the storage area. Because storage is costly. Storage is very, very costly. Storage is very costly. That is one of the major headaches of any company. Unnecessarily, you do not need to store a 1-year-old file, which is which has aged. You are not using it at all. So maybe a company's policy is like in telecom. If you have worked with any telecom company, like anyone, big giants like AT&T or Vodafone or O2 or 3, they have the company policy, or maybe they are governed by the telecom regulatory body. Like in India, it is TRAI. They specify that maybe you have to store Vodafone, O2, 3, AT&T. They have to store the records for the CDRs. It is called call data records. CDRs, I mean, each and every call that you make over your mobile phone or your landline phones or your satellite phones, whatever it is, they have to be stored. Each and every call record have to be stored for 7 years. You cannot make it on your own for 3 years, because the police department, anything, they can access the old record for at least 7 years. Law enforcement agencies. And whenever they demand that record, you have to, because you have to go after the criminals. Okay. So I cannot violate this. So company spends a lot of money, because can you say per second, per 1 second, there can be millions of calls. And can you think of how many terabytes and petabytes of data that has to be stored for 7 years? But anyway, that is the different question. So storage is always a costly thing. So therefore, every now and then you have to check the aging. If some record is more than 7 years, you have to clean up and free up the space. So that is a major activity always in the background. Any questions? So continuous deployment release pipelines. Now we come to the release pipelines. Till now we have been discussing about the build pipelines. Now we come to the release pipelines. What they do? Release pipelines. See, release pipeline structure, organize stages for deployment workflow. So that the release pipeline will define the deployment workflow, how you deploy the already built images or packages. Then you decide on the environment where you want to deploy the artifacts that have been built. Okay, so you define whether it's a dev or whether it's a testing. QA means qualitative quality assurance. Okay, and the production. So where you would like to target the deployment for, so it has to be, the environment has to be defined within the release pipeline. And then you have to wait for the approvals, manual validation points before deployment. So I have to stop there till I get an approval. So there is a gate. This needs an approval. So the pipeline is waiting for an approval to happen. Once the approval is obtained, automatically the pipeline will go to the next stage of deployment. So it will be deployed or delivered to the environment that has been designed for the locations. So the release pipeline in Azure DevOps define the process of deploying artifacts to various environments. Unlike build pipelines, which focus on compiling and testing code, release pipelines concentrate on deploying the resulting artifacts to their target destination. Okay, as simple as that, no complication. While classic release pipelines use a visual designer, the modern approach uses multi-stage YAML pipelines. That is it makes your life very simple. You can code your deployment, coding the deployment. That is fantastic. That is in your hands. Coding the deployment or the release. You do not have to depend on what is available to you. You can do it and manage yourself by writing YAML pipelines, which are release pipelines, to do the deployment as per your design. That define both build and release process in a single file. So you need only one file, release pipeline file. That's all, YAML file. This approach gives you the benefits of pipeline as a code. You see, you are coding the pipeline, including version control and reusability. Any questions? So deployment task, what is the task involved into a deployment? You do not need to worry about all these diagrams, but yes, Azure DevOps provides specialized deployment tasks for various target environments for Azure App Service. Now, you also do not need to, because everything is already designed for you. You have to pick up the particular Azure App Service deployment. The Azure Web App task handles publishing your application to web apps with option for deployment slots and configuration. Everything is inbuilt for you. You just have to call according to, depending on what your application is, whether it's a Java application or a .NET application or a PHP application or a Python application or a C++ application, whatever it depends on. So you call that particular service deployment. That's all. It will be automatically configuring according to the environment that is needed, that is required for your particular application. Database deployments can use the SQL Azure DAC deployment task. So everything is built as a task. I will show you. To apply schema changes with DAC files or SQL Azure. So SQL, this is the one that will solve your database queries and database deployments automatically with this inbuilt task that is designed for you. For script-based updates. For container-based application stacks like Docker Compose. So somebody is learning Docker with us, they will also learn Docker Compose. So how you do it and deploy the application along with the dependency on the between the two containers. This is one container having the application, say Java application, and this is another container having the database. So your application will talk to the database, and the database will provide data and updates and read all these facilities to the application. So they need to be as one release package and deployed. Okay. And when you do an image wise, so image deployments, or when you build images of the application of the database, then it is Docker, and you use a mechanism called Docker Compose, where this is a microservice, right? This is a microservice. This is also a microservice. So any container having any application, whether it is database application or web application, whatever it is, app, these are deployed as microservices. So you can have one Docker Compose file, like the Docker file. You have a better version of Docker file is Docker Compose instead of Docker file. Docker file is a bit backdated. Backdated. Is nobody uses Docker file nowadays. Yes, for small tasks, you will use Docker file, but you better use Docker Compose if you have multiple services to be deployed as microservices together. Okay, in one single file. If you had to deploy 3 microservices, you have to have 3 Docker files instead. 3 Docker files. And to link up each Docker file with the other is a Herculean task. Whereas with the Docker Compose, you have your own network where each one Docker, every Docker container can talk to each other over the Docker network. Here you have to establish the network between each of the containers. I do not go into complicacy. I want to make my life simple. I will use Docker Compose. So what it is doing, so that Docker Compose is also inbuilt as a task within Azure DevOps. So your life is actually made very simple. If you want to deploy as a Kubernetes on a Kubernetes orchestration, you have the Kubernetes manifest. Helm deploy is on the Kubernetes architecture orchestration. So that will facilitate deployment to container orchestration platforms. We will learn Kubernetes over 2 sessions after today. After the Azure pipelines. So those are orchestration platforms like Kubernetes. You deploy it over Kubernetes, whether now that can be an Azure Kubernetes services or AWS Kubernetes services. So AWS Kubernetes services is EKS, whereas Azure Kubernetes services is AKS. For Google platform, it will be some other GKE. Okay. So EKS for AWS. This is a SaaS, software as a service. So you do not have to do a lot of things. You just have to use the Kubernetes services from the EKS of AWS, which is everything will be given to you. So your life becomes too easy, too simple. Earlier deployments can take it can even take several weeks to do a deployment correctly. Several weeks. Design, getting the approvals, develop the scripts and all those stuff. It can go up to weeks. But here now, within an hour, you can design the entire pipeline with the release and the build pipelines done. Within an hour. Everything can be built up. Each deployment task provides specific parameters to control the deployment process, including connection information, deployment options, and rollback settings. Yes, rollback is a very important consideration when you try to deploy. You must, if nothing is perfect in this world. You cannot say whatever I am doing will not face any issues. It can face. The deployment that you have planned may have failed. Okay. So what you have to do, you have to restore back or roll back to the earlier deployed stage. You have to give it back to the production with the same as it was running earlier. Otherwise, what will happen? There's a lot of, penalties. If your system is down, it can cost you a lot of money. So I cannot risk a deployment with something happening wrong and I do not have a rollback settings. That is going to be a disaster. This is actually a important aspect of any life of a DevOps engineer or a development engineer or an operations engineer. Okay, so you have lots of types of deployment. Blue-green deployment is one of the major and most popular deployment nowadays. So there will be no downtime. That is the buzzword, because no customer would like to have their business downtime. Sorry, downtime. No customer will allow you not even a 1 hour. 1 hour is a big time. Can you think of Amazon going down for 1 hour? Leave aside 1 day. 1 hour down, like say Microsoft servers are going down for 1 hour. It can be a hue and cry all over the world. Huge billions and billions of dollars will be lost over 1 hour of business down. So no downtime. That is the buzzword. And for that, you make arrangements with this all technology such that automated downtime deployment, as well as using some mechanism to roll back if something goes wrong. You will restore back to the blue state. You are trying the green state, but something has faltered. You restore it back or roll back to the blue, which was there. Otherwise, if your deployment is 100%, you will transform your blue to green, which is the desired one. So your release 1.0 will now be 2.0. A new version of deployment has happened. Any questions by anyone?
No, sir.
Hello?
No, sir. No questions, sir.
Okay. See, whenever we are dealing with release, configuration, deploying from one environment to the other environment plays a key role. Without environment, you controlling the environment, deployment becomes a big nightmare. So you have to do some configuration, but don't worry. Everything is there in form of a task. So there are inbuilt tasks for you to do the configurational settings. Say what will be your default working directory. Okay, so it will be defined under the system. What will be the file type? What will be the target file? Where, what is the settings? You defined a JSON file with the entire settings. So all these are provided by this particular task. You just include that task. You get it from a list of tasks given by, I will show you that. And therefore, you can also have the security of all the important connection, subscription, and you can store your passwords and uh, passkeys. Uh, I mean your credentials. All these things can be stored. So for that also you have the I have a task. So you just have to give whatever the your connection that you have created, okay, by the name. That's all. I mean, there are lots of facilities inbuilt. You just have to know and use them. That's all. You don't have to code anything. So as I was saying, this is a very important part to understand in a release gate or in a release pipeline. So approvals and gates. So a pre-deployment approval, you have to wait for some manager giving an approval. Okay, so this is the pipeline. Now, before you deploy anything, you have to get a approval from somebody who will be mailed by the system. You have to configure your pipeline like that. Manual validation steps. So you validate whether everything is fine. I can give a go ahead. That require designated individuals or groups to approve the deployment before it proceeds. Approvers receive notifications or mails and can review the build details before making their decision. So once a decision is made, yeah, with all the notifications, yes, I can give a go ahead. I have no problems. My budget is sanctioned. My timelines are, it is within the timelines, and I have to fulfill the delivery milestone. So I give it a go ahead. And all the validation checks are done. Now, after the approval is there, the pipeline will go for the quality check, quality gate. So there will be some automated checks that verify specific conditions before allowing a deployment to proceed. Even after the approval is there, because the manager doesn't know what is the quality of the of the deployment. He doesn't know. He doesn't need to know. He gives the approval. Yeah, please go ahead. But he knows very well there will be some quality checks in the pipeline in the next stage. So the quality gate, let's say there is a sonar cube check before it is deployed to some environment. So automatic checks that verify specific conditions before allowing a deployment to proceed. Common gates include verification of test results, code coverage thresholds, and vulnerability scans. So the code smells. Code smells. So there is some bugs, but I will have a tolerance level. Tolerance level. These are all defined within the Sonar Cube or any quality gate softwares. So if it is within the tolerance level, I will let it go, pass it. And whether there is a code coverage threshold. So I say my code coverage means whatever, say there is 1,000 line code or there are hundreds of codes. Okay. And how much percentage of code coverage I have checked for quality. So let's say the code coverage is more than 85%. If it is somehow less than 85%, I will fail it. But if it is more than 85%, more or equal to 85%, I will let it go. I do not need 100%. No, not needed. The code smell, I do not need 100% to be code smell free. Not needed. Not needed. I will have a threshold and the vulnerability scan. So what are the percentage of bugs? If my percentage of bugs is less than 10%, I will allow the code to pass out. So these are the various decisions that has been configured over the tool, which can stop the deployment at that point. It will not let it go to the next stage, or it will allow. Now, there are some automated checks. This is a quality check. And these are some functional checks. So programmatic validation such as health endpoint monitoring, Azure policy compliance, Azure monitor alerts that ensure the environment is ready for deployment. So if everything is fine, that means Azure monitoring tool has no alerts. Okay, there is no violation. The policy compliance is 100%. Okay, for the security compliance. These are non-functional checks. Functional testing has already been done. Where? With which pipeline? Can anybody tell me? The functionals, the system integration testing, that the testing that is performed by the quality assurance team or the testing team. Which stage? With which pipeline? These are non-functional checks. The functional checks have already been done with which pipeline? Can anybody tell me?
Pre-deployment approval.
Yes, the build pipeline. This does not have any obligation or any scope of doing functional validations or functional testing. That is a headache of the build pipeline. Here we are talking about the approvals and gates, part of the release pipeline. So quality gate, approvals, automated checks for security alliance, compliance, Azure monitoring checks, programmatic validation, health endpoint monitoring, whether it is going to the correct, there is the health endpoint. So whether it has been, you are deploying with the correct orchestration tool, or the endpoints are having some feedback points mechanism, such that every time I can monitor the health. So all these checks are done, whether it is all are included. Hello. So if it passes, then finally it goes to post deployment gates. Now you have deployed, but after the deployment also, I mean, after you have released or deployed over onto the pre-production server or the test server or the production server, production machine. Validations post deployment is also very, very important. Validations are performed after deployment to confirm success, such as smoke tests, synthetic transactions, or monitoring for increased error rates. So there is a load testing, not load testing, I will say that there are few tests which can increase the error rates, and whether you are being able to monitor those failures correctly. So that will also be part of the post deployment gate. Smoke test, if it passes the smoke test, synthetic transactions. So that means atomic transactions. So there will be some mock atomic transactions, such that when it starts, like the banking, you are debiting and crediting somebody's you are debiting your account and you are crediting somebody's account. If one of them is success and the other fails, will you say that the process is 100%? No. For a banking transaction which has to be atomic, I cannot afford to have only one part success and the other failure and we pass it. No, it has to be atomic. Both the process, both the activities have to pass. Debit, your account is debited, whereas the other's account is credited. When this happens, your banking transaction has successfully done. So all these tests will be performed after the deployment has been done. Okay. Any questions? Any questions?
No, sir.
So you can have your build. So can somebody please mute? If you have no questions, can you please mute yourself? So you can ask me whether it is always mandatory to have the build and the release pipeline separate. Hello. Hello. Can you please mute yourself, please?
Sir, it's Kalkey ID, sir.
Oh, it is my people. Okay. So what is happening is it is not mandatory that you need to. Oh, sorry. Is the screen visible?
Yes, sir, visible.
Okay. So it is not mandatory to have two different pipelines. You can do multi-stage pipelines in one single pipeline file. In a single file, you see, this is a single file. So the entire CI/CD integration and delivery deployment process can be handled over one single YAML file. So you can define your multiple stages, but in a single file. But I will always suggest that you have two separate YAML files, one for the build and one for the release. Any question? So don't worry about the templates. Templates are a bit, when you know a bit more how to use. I will say initially when you start writing YAML pipelines, do simple without doing the template. Templates will help you to do advanced things. But as a starter, you should not be using the pipelines. You do your pipelines using your own pipeline scripts. No need to use any template. So you better use your Azure pipelines.yaml. Okay, you do it on your own. That will be best. Now, pipeline variables and secret management. Secret is your security. So there are variable groups. There are the secure files, Azure Key Vault integration, secret variables. So it is basically either you can go by the variable groups for using the security configuration, or you can use secure files, all the sensitive data like certificates, private keys, or configuration files in a file. Or you can do it with the variable groups, or you can use the Azure Key Vault integration. So there is a API. Just you call that API, and all your important data and whichever variables that you want to link it to the vault can be stored as a vault. And then after you can have your secret variables, mark the variables as secret. So that is very important. You can design a variable as a simple variable, then just mark it as a secret variable. That's all. Whatever data you store into that variable will be secured by Azure. So effective secret management is crucial for pipeline security. So what we say is a pipeline security. Your pipeline should be, whenever you learn DevSecOps, that is the cyber security. See, DevOps. Why you learn DevOps? Because DevOps will produce the assets, and DevSecOps will secure those assets. So a combination of DevOps and DevSecOps will give you a very important edge in the industry. Because whoever is requiring DevOps skills will also need, at some stage, you have to upgrade yourself into learning DevSecOps as a part of cybersecurity. Because as more and more AI and comes into the picture, your only knowledge on DevOps will not help. You need to go to secure your assets that you have created, the infrastructure that you have created, the pipeline that you have created. You have to secure them. So environment, as I told you, environment management is one of the important things. You will create your environment. Environments in Azure DevOps represent deployment targets such as Kubernetes clusters. Most of the deployments happens on Kubernetes. So DevOps has all the tools. Azure DevOps will have the inbuilt tasks, how you can easily deploy your development on the Kubernetes cluster. So the microservices can be deployed easily on the secured Kubernetes cluster or virtual machines or cloud services. So already the environment security is inbuilt within the pipelines. And then after you also have the resource management utility within the pipeline. So register and track the specific resources within each environment for which you want to track the resources. So you want to have the Kubernetes namespaces or web applications. So we will learn Kubernetes, then we will understand what is the Kubernetes namespace. So you are compartmentalizing your applications, your microservices. Okay, so you would like to put your database applications into a separate namespace for security reasons, and which anyone outside your domain or outside your development, I mean your company, nobody else from outside can have an access to your data. Data is most important part. They will only access your application, and application will, so there is a segregation of what you can access and what you cannot. And that is where the resource management through the pipeline can happen. So basically, this is the part of environment management. So as I was describing, today's world is deployment, how good you are in deploying or the concepts that you. So that the most important part today is the blue-green deployment. Few of the companies also go for canary release, feature flag, on-off deployment, and rolling deployments. These are the few important types of deployment strategies that you need to have an understanding of. But most of the times you are working in an organization who deploy having a strategy of blue-green deployment. So you are maintaining two identical production environments. So this is one production environment, and generally it is a costly mechanism. But yes, if you don't want any downtime, you cannot. It is like, let's say this is a live environment, the current environment, which is, let's say, blue, the existing one. And this is the future, the one that you are upgrading. So this is the green. Both are production, both should be running in parallel. Deploy the new versions to the inactive. So this is inactive. This is live or active. So all the traffic is diverted to this box because this is live active. No traffic is diverted to this because this is inactive. This is made ready for any future versions upgrade. Deploy new versions to the inactive environment, test it thoroughly, then switch traffic from the active. Now, when this is ready, 100% tested and approved. See, all this time when you were testing and doing this thing, this production box is on. This was off. Now, once you are 100% sure, tested, approved, you divert all the traffic from here, you make this off. You make this on and divert the traffic from here to here. Are you getting me? So you are making this off, you are making this on. So the entire traffic does not know, the users don't know what has happened in the meantime. They are suddenly finding that they are working on release 1.0, which was the older version. Now they are working on 2.0 without their blinking of the eyelids, blinking of the eyes. They are transparent. They do not know what has happened, but they are continuing their operations or working with the system without their knowledge that it has already been upgraded. So then switch the traffic from the active environment to the newly updated one. This provides instant rollback capability. Now, suppose even if you have tested, because you are doing some testing, but you may not end up, you see, a production environment or production box is a total different ball game. Now, even if you are 100% sure and you have diverted the traffic, okay, to version 2.0, suddenly some issue has cropped up. Maybe it can be performance issue, maybe it could be security issue, maybe it could be functional issue. Whatever the issue is, there is an issue. No system is perfect, no deployment is perfect. So you must have some rollback capability. Again, if you encounter the issue and cannot be resolved or on the fly, you will divert the traffic, you make it off. Before making it off, make this on, just switch it on and divert the traffic back. That's all. So you have rolled back to the version 1.0, which was working. But without the knowledge of the customers or the users using the system, that it was upgraded to 2.0, there was some problem, it has again reverted back to 1.0. Any question? It can be a very popular question in any interview. Now, canary, can you see a small bird? It's called canary. Okay. Why canary? Because our rollout, that means deployment, changes to a small subset of users, not full. So if 100% of users were on this box, you have picked up, say 5% of those users, put it onto the new deployment and check whether everything is fine. Then gradually you divert 5%, 10%, 15%. That way, the entire 100% traffic will be diverted. So that is small releases, small rollouts. Start by routing a small percentage of traffic, that is 5%, to the new version, monitor for issues, and gradually increase the percentage until you have reached 100%. This minimizes the impact of potential problems. This is one go. You do because you have done it like 100% testing and everything on a production environment, the same environment. Both are same environment. Here there is no traffic, here there is full traffic. So here there is 100% load, here there is no load. This is blue-green deployment. Whereas you take 5% of the traffic, divert it to the new release and check, observe for a day, maybe. Okay, so 95% is working on this old system and only 5% is working on the version 2.0. So test it for one day. Check if there are any issues. So the next day, if there is no issue, you do it for the another 10%, another 15%. That way, after say 7 days of canary deployments, canary releases, you have diverted 100% of the traffic. This is canary release. Feature flag, as I told you, on and off. Implement conditional code paths that can be toggled on or off without redeployment. This allows features to be released to specific users and gradually rolled out while keeping the code deployed to all environments, separating deployments for feature release. This is not that popular because it has a lot of, you have to be very controlled. Your mechanism of deployment has to be very strict and very much organized. Otherwise, this cannot be taken care. It takes a lot of expertise. And the rolling deployments. Update instances of an application incrementally rather than all at once. This is all at once. This is also all at once. Application wise, I'm saying. Here it is incremental. This approach minimizes downtime by keeping some instances running on the previous version while others are updated, allowing for graceful transitions with reduced risk. This is also very good. These three are very popular, but this is the most popular. Any questions? And therefore, after you have deployed, post deployment, there are few things like monitoring and logging, and these are all done through Azure DevOps tools. You do not need to do anything. You employ those tools. Azure Monitor Integration, there are tools. Application insights, that means you are finding out whether the performance is happening as per the re- required uh, expected level. Log analysis. So there should be a mechanism of analyzing the logs. So there you have heard about SRE. SRE is now becoming very popular. Okay, so this is a, a system resource engineering. That means this is mostly from the operations team with experts like DevOps who are good in doing SRE. So basically this monitoring and logging. So there is, you have heard the term or the tool called Kibana, Grafana, Logstash, Logstash. These are the various tools that will help you, with SRE and various log analysis, application insights, and monitoring. All these tools can also be provided by Azure DevOps. Azure DevOps is one application from Microsoft which gives all these tools available to you. You do not need to go for Kibana or having buy the Grafana or Logstash as part of SRE. Everything is inbuilt within the Azure DevOps. So it's a very, very popular tool. And therefore, there is also the how you error handle and provide the notifications. You basically determine the task conditions, retry logic, email notification, and chat integration. So all these chat bots and everything can also be integrated with the pipeline. Your pipeline can throw email notifications to the respective for approval requests and all those stuff. Okay. Error handling. Pipeline security best practices. You have the service connections. So you are getting a service connection to the various external services, but through a very, very secured mechanism. Sorry. And those are given by Azure DevOps only, service connections. So you make, let's say you have GitHub, and here is your Azure DevOps. Okay, and your pipelines are getting created over here. But the pipeline needs to be getting integrated with the GitHub, because your development source code all is over here. So you have to fetch them, integrate on the pipeline. So what you need to get a secured connection. So all this is called the service connection. And this is very secured because it is provided by Azure DevOps. So, and it is very simple to get this service connection established between the Azure DevOps pipeline and the GitHub. It can be Docker Hub. It can be any other external like Azure, Nexus for the repository. Instead of using the Azure repository, you can use Nexus. So there will be a service connection with the pipeline to integrate with Nexus. Like you have Terraform. which is external to Azure DevOps. You will have a service connection to Terraform. And as long as the service connection is working, you can easily integrate Terraform and Terraform services over onto this pipeline. Is that clear?
Yes, sir.
Yes. And basically, these are all secure coding practices. These are all enabled within your pipeline. I mean, Azure DevOps. Access control. These are, you see, these are the modern way of giving access. So you should be aware that there can be hackers, there can be so much of issues. So you must go by the standard principles or standard practices. You do not need to worry too much because these are all inbuilt services that are provided by Azure DevOps. So protect your main pipeline configuration files with branch policies requiring code reviews and build validations. Consider using environment approvals for production deployments and limit who can override failed checks. So all these configurations you can do over the pipeline. Like as I was saying that you can integrate with the external tools. How? With those service connections. So that is a GitHub integration. Connect Azure pipelines to GitHub repositories to build and deploy code stored on the GitHub while leveraging Azure DevOps powerful CI/CD capabilities. This integration supports triggers from pushes, pull requests, and even GitHub Actions workflows. Even the webhooks can be integrated over onto the pipeline through the service connections. Jenkins. Jenkins is another pipeline. So you have, let's say, you have a build pipeline on. It is a very weird combination, but let's say you can also do that. That is to say, a build pipeline on Azure DevOps and a release pipeline, though Jenkins doesn't have a release pipeline, but I'm saying just an example, or some of the activities on a pipeline given by Jenkins. Maybe Jenkins is good in that. So you took that from Jenkins and integrate Jenkins with Azure DevOps pipeline through this. So incorporate existing Jenkins job into your Azure DevOps pipeline using Jenkins task. See, again, the task came into the picture. The task, you just have to call the Jenkins task and the integration will be done automatically. Container registries. So you can integrate with Docker Hub. As I was saying, Docker Hub is a place where you can have all your images stored. We have understood that in our Docker session. So this is an external tool, but you can easily integrate with the service connections and whatever. So see, for pipelines, these are the you see these are the pipeline script, a simple pipeline script. As I said that this you have organization that is on the top of the sea. This is, if this is a pyramid, so on the top of the pyramid lies what? Organization. You cannot start a project without an organization. So on below the organization lies what? Anyone? On the topmost is the organization, is the project. Without a project, you cannot create a pipeline. And then in the pipeline, let's say this is the pipeline, and within the pipeline also there is a hierarchy. So there is, first is the stage. What will come after stage? Within the stage, you can have jobs. You can have job, one job or multiple jobs. And within each job, what is there? Finally, the work
Task.
is there. Task. Very good. Final intention is to build the task within the job and within the stage. So stage, job, task, and there you write all those tasks that you want to do. And while doing the jobs, the jobs can be sequential. So this is job one. Then the pipeline goes to job two. Once the job one is complete, it goes to execute job two. If the job two is complete, it goes to execute job three. This is sequential. And then within the stage, so this is stage, job one, job two, job three. Another can be the same stage. You can organize the job as job one, job two, job three. So you see at the same point, all the three jobs starts together. So these are called parallel jobs. So they are starting together, not sequential. This job does not depend on this job for the completion. Okay, or to start this job, I do not need the job one to complete. They will start together. Maybe this job will have again a sequential job 4. Then job, so they are not parallel. So job 3 will complete, will start job 4. Job 4 will complete, start job 5. But job 3, job 2 and job 1 can start together. Is that clear? So here you define the clause as jobs. This is the JSON key. JSON key, because you are writing YAML. And this is a sub key and a value. You see, key colon value. So this is another within the job. This is called parallel. These two jobs are parallel. These jobs are running in parallel. What is the job name? The job name is build front end, and this job name is build backend. But they start together. So the tasks will follow the job, and then you say steps on the tasks. Basically say steps, and you write a script. That is, you are saying the npm build. So you are building the backend, not the backend. I mean, for say React.js or React Native or Angular or Vue. So all the front ends which will run, but you have to build the Node.js engine first. So you will do an npm build. So very simple. And for the backend, let's say backend is provided by Microsoft.NET. Okay, so this job will parallelly start .NET build, npm build, and .NET build. So this front end for React, Angular, Vue, and for the build backend, so .NET applications using the .NET build. Anyway, that is besides the point. And this is a matrix strategy. So it depends on your strategy. This is parallel job strategy. You say, here I have a job by the name test, but I have a strategy within the job. And can you see that they are working on the same level? So this job has a strategy called matrix. So the matrix is like, what is your operating system? If it is Windows, then the OS being used is Windows latest. And the framework is whatever the framework. Linux, if you are using a Linux matrix, then the OS you are using may be Ubuntu. It can be Red Hat latest. Let's say I'm using Ubuntu. But if it is Mac OS, can you see Mac OS? You are using Mac OS latest. So depending on your platform or a matrix, so the strategy is to use this particular operating system depending on your platform. And the pull. Pull is nothing but, the pull is nothing but your VMs or virtual machines that you are going to use, or the servers, the virtual servers. And this virtual server is provided by, this server is provided by whom? If it is not hosted by you. If it is not, there are two things. Self-hosted servers or Microsoft hosted servers. So this, whatever it is, called pool of servers. Now here I am using, whenever I'm saying VM image, I am basically using a Microsoft's hosted server. And that hosted server is using $OS. Now, can anybody tell me which OS I'm going to use? What is that $OS? It is basically the matrix. It follows that matrix strategy. So if my framework, if suppose my software is deployed over Windows, then the OS is Windows latest. If it is on Linux, it will be Ubuntu. If it is on Mac OS, so it is asking Microsoft to host a server depending on the OS or the platform, that is based on this strategy. And after it has been determined which is the OS, we will go to do the steps directly. That means I have no jobs. So my job is one job. It is only one job. Under this, I'm making a strategy, and therefore I'm using the task or the steps to, doing some test. This is the variable and the extrapolation of this variable with a $sign. Framework is the variable. So net 6.0. So that is the framework that we are using. And you are going to do the test on the image or the VM image, virtual machine image, which is a Microsoft hosted server. Any question? Artifact management is not important. Infrastructure as a code, now we have already understood. Everything is like a, so you version control is a GitHub. GitHub is also something which stores your code with a version managed. You will define the infrastructure. So what can you do with? So you can do it with Terraform. This is GitHub. This is Terraform. Test templates for errors and best practices. So validate. So you can have many testing tools over here. And finally, you deploy it over the provision the resources automatically. So everywhere. So here it is the pipeline. Everywhere you can code through the scripts. Simple. So here it is pipeline, Azure DevOps pipeline. So test codes like on is scripts on the Selenium test bed, Terraform, and this is GitHub. Okay. Infrastructure as a code allows you to manage your infrastructure using configuration files rather than manual processes. Azure DevOps supports multiple IAC approaches, including ARM templates for Azure specific. So don't go about all these things. That is too advanced to understand or explore at this stage. We'll skip this. So container-based CI/CD, whenever you are saying that you want to do the entire deployment based on containers, then you follow this path. You container file or a Docker file or a Docker compose, as we discussed. Docker compose is a utility or a tool coming from Docker. So the container build instructions, you put it into that file, Docker compose or Docker file. It will build your image and put it into the container. So therefore, the packaged applications and dependencies. So you build the Docker images out of the Docker compose or Docker file. So Azure container instances. So serverless container hosting for simple workloads. This is where your pipeline integration comes into picture and does the services. You remember that those services and tasks that is inbuilt within Azure DevOps that will help you to serverless, because you are not worried about which server you are getting hosted. So the container hosting happens serverless to you. Okay. And finally, you deploy it over the Kubernetes. Orchestrated container management for scalable applications. So these Docker files or the Docker images will need to be deployed on a containerized or orchestrated container management for scalable. So for scalable applications like enterprise level applications, where it has to be scalable. That means today there are 1,000 users. Tomorrow, after a year, it can be 1 million users. 1 million users. So your application should be able to cater to 1,000 users very simply, and also with the same performance for 1 million users. There will be no performance degradation. That is called scalable application or enterprise level applications. So for that, you cannot sustain with an application which cannot scale up itself with all the security features, monitoring features and everything. So we need to have it deployed over this thing. Any questions up to this point? So if you can deploy your applications over CI/CD, you can also deploy your database. Yes, you need some uh, like the data tier application data package. This is already inbuilt within the CI/CD. I mean the Azure DevOps. So this sort of packages will help you, or tasks will help you build your or database applications build process. Okay. Strategies, testing strategies in CI/CD, automated UI testing, security testing, load and performance testing, chaos engineering. All these are strategies, various strategies of testing. So chaos engineering, deliberately introduce failures to test your system resilience. How much resilient is your system? You introduce errors, bugs inside the system and check whether your system can still sustain. Suppose you suddenly make your network heavily loaded, okay, or you enables few services going down, make some resource constraints, and then you can verify that your application gracefully handles unexpected conditions and maintains reliability. These are various types of testing strategies. Load and performance testing. You have to do the security testing and user interface testing automated. You would be using tools like Selenium, Cypress, Playwright. Selenium being the most popular. There are lots of things in Azure DevOps. Okay. Is anybody there?
Yes, sir, there.
Okay, fine.
Yes, we are.
Uh, I just can show you the interface. There is not much of time to explore anything much more than that. So you can see that the interface. I just can go there and check the interface. So let's say this is where you will be. See, there are two parts. One is the Azure portal, which is the Azure cloud, Microsoft cloud. And within the Azure cloud, there is the Azure DevOps, or you can go separately to Azure DevOps if you have your Azure account. Azure account helps to once the Azure account is created with some policy, you can explore all the Azure tools within the Azure cloud. One of them is Azure DevOps. So when you log into your Azure portal, this is the Azure portal, portal.azure.com. So you see, these are various, there are much more services, out of which one is the Azure DevOps. You can click on this and you can go into, because you have already logged into Azure portal, you have the Azure DevOps is a subset of a tool. And I have an organization called Debasis Kalkey. I am going to that organization. So I am there in Debasis Kalkey, and these are the various projects, because you have seen that the architecture, the hierarchy. Organization uh, is on the top of the pyramid, followed by your project, followed by your pipeline, followed by within the pipeline elements like your stages, jobs, strategy, jobs, uh, and the steps. So for an example, here you see this is your Azure DevOps. You have logged into your Azure DevOps and you have created your project. There are 3 projects over just for an example I have created. You can create your new organization. and you can embed or uh, configure the organization policies, configure organizations for many lots of organizational settings that you want to do, and then come to create a project within the organization for hosting this particular project. So let me go into one of the projects. So you are into your Azure DevOps project. Okay, you create a project. I do not have a time to show you from the scratch, but it is in our regular classes. We explore each and every bit of details. So on the left hand side, you can see there is, as I told you, these are the various tools available under the Azure DevOps. One is the Azure boards. It is like the Jira board. Jira is a project management tool. Similarly, within the Azure DevOps, you have all the project management tools that is needed to manage your project. Okay, like the Azure boards. You can create sprints, you can create your backlogs, delivery plans, everything can be done. So on the boards you can, and there is the Repos. Repos is similar to having GitHub within the Azure DevOps itself. You do not need to go outside. You can store all the resource codes or the development codes or resources within Azure Repos. It is exactly similar to the concept of Git and GitHub. Nothing is different. So it is as if the GitHub resides within the Azure DevOps in form of repos. Then the main thing is the pipeline. And if you can select, there is the project settings, or rather the organizational settings. You can have two types of pipelines. One is by default, there is only the build pipeline. But if you can do the project setting for having a release pipeline, okay. So you can, so here I have already configured my project having a build pipeline as well as release pipeline. There are two pipelines, build pipelines only having the name as pipelines is a build pipeline. And if something you see as releases, that means you also can design your release pipeline. So if you click on pipelines, and I have, just for an example, I have a few pipelines. All these are all build pipelines. Okay, if I go to the first pipeline or just a pipeline, and if see, I have created a pipeline. So these are the various runs on that pipeline that has happened. Only 3 runs have happened. But I want to check the pipeline. Okay, I can go and see the edit. Since my connection is not yet established, I mean, it is an old thing. I can revive the connection, whatever it is. Right now, it is not finding. So basically, this is the YAML pipeline. And if you want to go to this is, I have integrated GitHub into the Azure pipelines. You remember, we can have the service connections. So this service connection is part of the configuration that you do with the environment. Okay. I have created a connection to my GitHub. So this is the GitHub. You see, this is the logo of the GitHub, and my GitHub account is Debasis-Jiv. And there I have created a repository called DSA43 or whatever, Azure DevOps project 1. And over here I have created. So see, here I am not finding the code, but okay, that's fine because the service connection is not active. So I can directly go to my GitHub. See, I am there in my GitHub. This is my account. This is my account. and I can go back. This is my repository, that one repository. And here is my Azure 01 first Azure Pipelines YAML. You can just click on this and you can see that. Can you see the code? You are saying that the pipeline will be triggered when there is any activity on the master branch. Any changes that the developer puts any changes onto the master branch of that repository. So immediately the pipeline will be triggered. Which pipeline? The pipeline is 01 first Azure pipeline. It will be triggered. It will be run. And what is the pull that I'm using? I am not using the VM image. I've made a comment. Can you see? What does that mean? Can anybody tell me? I've commented out the VM image. What does that mean? That means I am not using the Microsoft hosted agents. I'm not taking help from Microsoft for the server. I have created my agent myself. This is an individually hosted or self-hosted agent by the name. So this has been created. There is a mechanism to create that agent. And in that agent, I have installed maybe Terraform or this and that. Basically, I have to do a lot of things installation because that is my customization that I'm doing onto my server, my individually hosted agent. Whereas if I had used the VM agent, VM image, I would have used the Microsoft hosted in this. This is the OS Ubuntu, and whatever necessary softwares you name it, everything will be available there. Terraform, Ansible, Docker. I do not need to install it separately. Unlike my self-hosted agent. My self-hosted agent, I do not have anything. I will have to install them. Only whenever I was creating this hosted agent, I had mentioned which OS, whether it's Ubuntu or Windows or Mac. That much is there, but the rest, nothing like no Terraform will be available, no Ansible will be available, no Docker will be available. I have to do it separately. Whereas if I had used VM image, I would have got everything ready-made. So the jobs, I do not have any strategy. That means whatever is inbuilt within I have built within the hosted agent will be used as my strategy, whatever the platform. And so I start directly with the job. So you see, this is the parallel jobs. Job, first job, second job will run in parallel, third job will run in parallel, fourth job will run in parallel. But at the same time, I have, see, this will start, the first job will be started automatically with these steps. So I'm doing some echo, very simple. So display name. So what will be displayed as a job? So that will be just run one line script. So that will be just name of that particular step. And here is the echo first job, hello world. So this will be displayed on the screen. When you run this pipeline, you will see all these things happening. Simple echo command. You see, this is a Linux command. Echo. I'm kept it very simple. And this will be shown you as that the script or the step is doing this particular run a multiple line script. First, it will run a one line script. It will be in the debug log. It will be displayed. Second job. But here I have used a clause called depends on. How does it change then? Will it be a parallel job or will it be a sequential job?
Sequential job.
Sequential, because it has a dependency you have been built with the first job. So unless and until the first job is completed, it will not start the second job. So it is a sequential job. by using just a simple thing called depends on. That is how simple it is. Third job. Now, this second job and third job will start parallelly once first job is completed. Why? Because the third job is also depends on first job. So immediately after the first job is completed, the second job and third job will start running parallelly. And then the fourth job. Fourth job has a dependency on second job as well as third job. So unless and until the second and the third job has completed, fourth job will never start running. So if I visualize this, see how simple it is. So when I visualize this, how shall I say? So this is the jobs. Okay. Which one will start first?
First job.
First job. Whatever the job name is, first underscore job, I think. It will start. If it completes, so now it completes. It will start
Second job and third job.
second job on the same line, on the same level, because they are parallel. The third job. Same time. Okay. And now both completes. Only one completed will not do. One completed will not do. It has to wait for the both the jobs to complete, then only it will start the fourth job. So you can have a hierarchy based on whatever design that you see, but it is so simple. Within the first job, what are the steps? It will just execute the tasks as a script. Script is one of the modules through which it will execute. So script is a shell script. So it is a shell command. You see echo. Or if you say script, if you want to run a Terraform job, what is that? You say Terraform. This is the shell command, Terraform validate or Terraform plan. So echo that is, and then you say script. Here, let's say in the fourth job, you want to do the Terraform apply auto. So basically, I'm writing the shell command for Terraform, which is Terraform CLI, Terraform apply auto approve. But actually, you are doing it through a task, which is script under the steps. So it will execute. But so to get this thing executed, what is my task? I will include a task from Terraform. I will show that. After that, we can take a we can end the session. See. So I go back. This is my GitHub. So I was showing you the code, the pipeline. This is YAML file. Okay, by the name 01 first Azure pipeline.yaml. I can copy this and put it over in my. So you can copy that entire thing because you have done it and just paste it over here. So and then you can save it and run it. It will run. Can you see on the task? So let's say I'm trying to get a Terraform task. Can you see Terraform, Terraform CLI, Terraform installer, Terraform tool installer? Maybe I do not, I have to have a service connection to Terraform. But here, you see, I am giving the provider. Let's say I have a provider called AWS, not GCP or Azure. Azure RM is the Azure cloud. AWS is Amazon cloud. GCP is Google cloud. Okay, so I am taking AWS. I am saying which command that you want. I am saying that I want the Terraform apply command. And you can use apply. And let's say the configuration directory is the default working directory of the system. So command arguments, you can say auto approve. This is the command argument. And if you say, I do not have a service connection right now, so no results found. But if you had a service, I will build a service connection to Terraform. That is a different topic. But then you add it. Can you see that there is under the, because I do not have a service connection to Terraform, it is giving some underline of something. Okay. And this task does not have some, you see, this task does not have any precursor. That means how suddenly we can start with a task. We are not maintaining the hierarchy. So where will the task come from? The task will be under the steps of jobs. So the jobs, you name a particular job, or you just start with the steps. If you have only one job, start with the steps. Within the step, you have the task. So it is, see how simple. Your command is apply, a Terraform apply. Whenever you execute this, you see, you can save this. And whenever you execute it, it will go to the service connection to connect to Terraform, and then use the AWS CLI to connect to the Terraform. And the Terraform will connect to the AWS cloud and do this apply, because on the Terraform, you have the Terraform scripts, which will apply from the root directory of Terraform, or whatever the project directory of Terraform that you have created, it will. So all these things are part of the pipeline script. But how easily I could create a task of Terraform apply? Can you see? Because I have discussed Terraform, that's why I'm giving this example. Is it okay?
Yes, sir.
So thereafter, you will say, you will save, and then you can run it. And if you run it, you will see, I will say leave, because I don't want to save it. I do not have the VM image, or nothing is there, so it cannot work. But you see, you can create a new pipeline, or you can select this pipeline and you can run the pipeline. You can go and check what happened into this. So this was the job. So it started the first job, second job, third job, fourth job, and successfully done. So you can go to first job. You can check the log. I think it was built quite long back. 26th of March. So it was long. So it is not finding all the relevant links and this thing, but let's see what it comes up with. So the first job, you can view the role, and now there is nothing is there in that. You see, uh, these are what is happening. Can you see that? Uh, this is the raw log file. That is what is happening behind the scene when you have called this particular simple job. So the task is the command line and echo. Can you see? First job, hello, world changed. So that was part of the script that you have executed. So first job, hello, world changed. So all these things. So get the sources where all the repository, the Git repository was the Git. So everything was run and it is showing you the log. Okay. So that way you design the, I could not show you the release pipeline there because the release pipeline is not yet been created. And there is our students have done a capstone project. You see, this is was a huge project, very good with Kubernetes, Terraform, Ansible, so many things included. So you can check the pipelines. Kubernetes cluster IAC pipeline. And you can go. I don't think it will be there. Uh, yeah, it is C. There are lots of C. Can you see the task? Can you see the task? AWS init.
Yes.
So Terraform init, then Terraform apply. And finally, it will destroy the EKS cluster. So basically, it is using the EKS cluster on the apply. So there is, and can you see the service name? AWS. I have given a service. But basically, I have configured Terraform, integrated Terraform with AWS over this pipeline. Backend AWS key, Kubernetes dev state. This is the TF state. This is the bucket name where all your state is saved, restored. And the backend service is the same service, AWS for Terraform. So lots of things can be done. See, this is the Docker push, pipelines, build and push the Docker image. All these stages are there. You can go to the edit. You see, I'm using Docker and the tag that I've used is the build ID. I'm copying the file. So whatever, uh, can you see everything is like a task. Task is what I'm getting on the right hand side. So for each of these tasks, I have the inbuilt. So basically, I have nothing to do. Everything is there for me to do. So when I say download the pipeline artifacts, I mean, you have seen that you have stored the artifacts, and now for deployment, you will be fetching those artifacts from a particular repository, artifactory. And then you are doing the Kubernetes, you are executing the manifest file of Kubernetes. You are using the deploy action. You have a Kubernetes service connection type. And thereafter, you are actually you are executing a manifest file to use the EKS cluster, Elastic Kubernetes Service over the AWS. And using that, Terraform is building that Kubernetes cluster over the EKS, and then you are using the Docker images to deploy over that Kubernetes cluster. Is that fine? It's a whole lot of project. It's a big project, but we have to know. But this is overall what you do in a CI/CD pipeline of Azure DevOps. Is that fine? I will just end the session today. I know it is very short time to say so a lot of things over the Azure pipeline. So better I will stop the discussion, stop the sharing, as well as I will stop the recording. So thank you very much.
Thank you.
I am not sure whether I will be available in the following weekend because I have some marriage ceremony to attend, but let's see. So thank you very much for your patience. For actually, this is on a Saturday evening. It is very difficult to concentrate, but yes, thank you for all your hard effort.
Thank you, sir.
Thank
Thank
you.
you, sir.
Thank you. Thank you. Hello, Shubro. Can you stop the live streaming? Okay, I will take a leave now. Thank you. Thank you, Ernest.